Again, in this, I think, fairly short segment, I'm going to talk about this thing that is in Miller chapter, the Growth chapter, chapter 9. The thing that I'm talking about is the rule of 70. I'm stammering and bumbling around this thing because I often like to call it the rule of 72. Other textbooks call it the rule of 72. Some call it the rule of 70. Someone has a rule of 69.3 out there. You see, they're all close to the ballpark, okay? So the first thing I'm going to say is it probably doesn't make much difference which one of these tools you were to use in real life. I know you want to get through the test, and Miller uses the rule of 70, so 70 is what you want to use. But in practice, it doesn't matter which of those numbers you use. The whole idea of this concept is to have an easy way to see what it would take for something, an asset or a liability, to double. So we're doing this in the chapter about economic growth. We're talking about growth rates of GDP. And so how long would it take the economy to double is what the rule of 70 is, or 72, is handy for. I actually do think of it. I do use this from time to time. It's just a little thought exercise. You know, you hear something growing at such a rate, and you ask yourself, to get a context, to get a feel of what that means, you say to yourself, well, how long would it take to double? Well, if you have the rate, you can find out how long it would take to double using this rule of 70 or 72. And I choose whether to use 70 or 72 based on whether or not it's a factor of the number I know. So let me explain. Based on whether or not it's a factor of the number I know. Okay, so hold that in your mind and let me explain the rule, and then I'll go back to why I'm using 70 and 72 interchangeably. All we're saying, let's focus on this idea of 70 because that's what's in the textbook. All we're saying is that 70, as it works out mathematically, is the product of something, rate times time, where that thing will double in size. So if I'm told, for example, that the economy is growing at, let's say, 7% a year, an economy is growing at 7% a year. In percentage terms, that's the 7 right there. 70 is the rule that I'm going to use because, going back to what I said about hold that thought, 70 is easily divisible by 7. So since this is something I would be doing like sitting on an airplane or driving my car in my head, I would use 70. I wouldn't use 72 because 7 doesn't go right into 72. 3s and 4s and things like that, and factors of 3 and 4, they go right into 72, and 6 does as well. So I would use 70, and so then this is probably becoming pretty clear. If something is growing at 7% a year, how many years will it take to be double what it is now? It must be 10. Just because 70 divided by 7 is equal to 10. So that's the rule of 70. You know, the rule of 72, if I was driving down the road and I was listening to my Rush Limbaugh or my NPR, whichever one you're into, and you hear, or I hear, this thing is growing at 12% a year. Well, I probably wouldn't use 70 because 70 isn't easily divisible by 12. But if I'm driving down the road, I think to myself, it's growing at 12% a year. How long would it take to double? Well, 72 divided by 12 is 6. It would take 6 years to double. That's all this is. It's in the textbook. It seems difficult. I know people have a tough time with it sometimes, but that's all this is. And that, does that sound about right? I mean, think about it. If something's growing at 7%, it takes 10 years to double. If it was growing at 12%, we would expect it to take less time to double in size, right? So 6 years sounds about right to me. So that's what these rules are and how you use them. I think they're pretty handy. I don't often use them for the idea of the economy doubling, but I do use them for the idea of an account doubling. If you have an account, you won't find this in a savings account now. I mean, interest rates are very low, but if you have an account in some kind of a tied up in markets where you might have growth rates of these kinds of numbers we're talking about, 6, 10%, things like that, you might ask yourself, if the market doesn't tank, if the value of this thing doesn't go south, because that's a pretty high rate of growth, so with big reward comes risk, and it might not continue on, but you might ask yourself, if this thing can keep going at the rate that it's going, how long will it take to double? That's just a reasonable thing to want to know. And that's what you do. You just say, oh, well, the rate goes into 70 how many times? And if that's too hard to figure out, you use 72. And if neither of them are easy to figure out, then use a calculator. Divide 70 by the number you know, and you'll get the number of years. And by the way, just to be clear, it works the other way too. If you wanted to ask a different question and say, well, if I hold this for 10 years, what rate would it have to be to double? The answer would be 7, right? Because it's just the product of rate times time. Rate expressed as a percentage times the number of years come to be the product of those being 70 is that rate and time that it requires for something to double. And that's all it's good for, is just simple back of the envelope in your head kind of calculations. That's what we're talking about with this issue of the rule of 70.